Chuck, I don't know if you want to run with me.
I can do my best to, yeah, sure. Do we want to
Yeah,
start?
it's fine to start.
I'm gonna move from the because I tend to jump around a lot, so it's probably easier for me just to use the handheld. Assuming, oh, maybe. Hello, yeah, that works, okay. I have to use my soft voice with this, otherwise it'll scare people. Okay, so welcome to the Unconference. So this part of the day is sort of modeled after something called a vocamp. So for the last, I guess, 6 years, I've been involved with this loose organization, motley organization of people who get together and try to build modular, reusable ontology design patterns for various things, particularly in the geosciences. So they've been called GeoVocamps at times. A couple of years ago, 2 years ago, 3 years ago, after Jane started at Notre Dame, her and I sat down and talked and said, what can we do to start thinking through how all this stuff works together? And I said, well, I'm organizing a vocamp in Washington, D.C. At the Department of the Interior. Why don't you come and bring some folks and let's sit down and see if we can at least figure out what this thing means as a concept, right? And go from there. So we spent 2 days working through what a drone is and all of its lovely complexity. And we came around with some patterns. So we pulled there's some existing patterns. One is called a semantic trajectory, which was used in GeoLink, which was a NSF funded project for the oceanographic sciences to describe cruises and various other things. But it's a very simple pattern that describes moving objects, right? So we sort of started taking that as a version of that's a plan. So that basically tells you, is a way of describing the waypoints on a flight plan. You can also use it to describe the trajectory by which the object moved. So in real life, the moving object. So it's a very lightweight thing. So we sort of identified that and a few other things. And yep, semantic trajectory. So way on vocamp's work, I guess I already started pitching my topic, so I'll just go ahead and go first, is we sort of give a rough overview of the potential interesting topics that people are wishing to work on, and then you sort of vote with your feet. If you find something that might be kind of cool to learn about or work on, or that you think you can contribute to, then you sort of say, yep, I'll work with that group. If you want to move between groups, that's it's okay, but it's generally better if once you've committed to sort of go through it. The exception is myself. I will be moving between groups. It's just because of there's some moving parts that I want to be able to connect to, right? So because some of these topics I sort of put forward as in my mind the way to go. Okay, so the first topic is to sort of extend this pattern that I alluded to. Here we go. Okay, so I know this is hard to see, but I will zoom in on it in a section. So what I did is I went through the concept maps that we had created during the vocamp and said, okay, what parts do we need to sort of flesh out? What parts can we bring in, and what parts can we leverage other existing things, right? And so anything you see here in blue is essentially fair game for ontologizing, okay? Anything that you see in red, that came from SOSA, right? So those are links to existing vocabularies that describe observations, measurements, sensors, all those sorts of things we want to leverage. This one lone guy up here, this green thing, it's thing, it comes from the Web of Things working group. So this thing that we're developing is also a thing. It's a web of thing. It could potentially be a connected thing. Manufacturers are making them connected things. And so a thing description is a way of creating a document that describes what a thing in the world is as a Internet of Thing. And it also describes what affordance is and how you talk to it and connect to it, right? And so that was sort of a way of defining in the world what a UAV description, which is bigger than that, right? Needs extension and work out, but it's also a subclass of a WT thing, right? So it shares some of those properties, okay? Purple. So there's two purple things, which I will actually zoom in on, assuming I can. Let's do this so I don't funk it. Actually, let's see. Yeah, let's just do. Okay. So this is the moving object. So this comes from that semantic trajectory pattern I alluded to. So that basically tells you how an object, as a function of time and position, moves through space through sort of fixed segments. So it gives you that mechanism in RDF to say things like that. There's an additional thing called a medium, and we can debate as to whether we even need that, but I put it there for completeness because the UXV, depending upon whether it's UAV, UUV, traverses different mediums, right? So one may move through air, one may move through water. You could probably infer parts of that, possibly. Okay, new things. All right, so the core part of this is a UXV, okay? So a UXV could be a glider, it could be a drone, it could be a car, autonomous car. It could be anything that's an autonomous something vehicle, right? And so it has a partness relationship, right? So there's a bunch of has-part relationships that you'll see here, right? And so it has part body, right? And there's something that describes that body, right? There's a body description of some sort, property that is probably symmetric. For a UAV, so a UAV is a subclass of a UXV. UAV has part airframe. So that's an example of what you could do. And because if you have a UAV has part airframe, that's body, you can basically, even with these parts here, infer that if you have something that's a UXV that has a body that's an airframe, that it's a UAV. So you could do some interesting logics there and not even have to specify that, right? So machines can sort of figure those things out. It also has a part that's a payload, right? And so the payload for you guys is very important, right? But there's a general payload description so that Domino's, when they drop off your pizza and they want to describe the payload that's being carried, they've got a hook to be able to do that, right? So there's an information object which could have a realization, right? And then you have a particular type of payload, which is a sensor payload, which is a subclass of a SOSA system. You also have a payload part that is, or you have a part of a UAV that's a controller. And we actually spent quite a bit of time at the VoCamp talking about this. And one of the things that doesn't exist that's a stub right now is a world model, right? So controllers basically have some view of the world that they use to, and this comes from robotics, that they use to essentially do motion planning, navigating, all these sorts of things. And so that basically gives you a hook to the robotics thing. It has a part communication system, right? So generally these things will have, either onboard telemetry radios, or they may not, but we want the ability to be able to capture that. They usually have a part ground station. Which is this sort of stub class. So things that are in yellow are stubs. We know that they're more complicated things. We know that they have a relationship here, but they're probably outside the scope right now because they could take an entire afternoon. And then there's a participant relationship. So there's a thing in the world that's an event. So this is the event ontology design pattern, right? So there's a mission. The drone is a participant in that mission. And then there's a mission description and usually a mission plan. And so these are sort of the places where this morning when people were talking about, doing these workflows of, I go and I check the FAA space and I do all these other sorts of things, those sorts of information objects could sort of fit into that. So this is just a back of the envelope sort of thing, but hopefully is useful in talking about and grounding these things and pushing them forward. I will say one last thing in that, and it may be, let's see. The link to the no, the BMW, the is that in the notes? I did. I just don't remember. I think I put it in the agenda where, yeah, okay. So there's, just so you know, in the agenda at the top here, there's some background stuff that you may find useful. And so there's sort of general ways of doing APIs and linked data, which we think is really, really important. And then there's some other sorts of things down here on terms of ontologies, right? And so there's two things that are kind of relevant for this. So the first one is, oops, that's not what I wanted. Not doing very well at this navigation thing. VSSO. So this was developed partially by the BMW group. And there's a nice poster that they have, which I won't put up right now, for how they're thinking about self-driving vehicles. But this is basically a vocabulary, but it's also aligned against other sorts of things. And so I have kind of in mind a VSSO that is a UXV sort of thing. Where you have these sort of links to other vocabularies and ontologies. So so for example, right, you have a way of saying that there's an engine, a VSSO engine that is part of a vehicle. So that's that partness relationship that I alluded to. And you can give all kinds of information objects about that. So properties of that thing. And then you can say that that thing has a property, which is a temperature, right? It's a thing that you can measure about it. And then if you go down, you'll notice that it's an observation. And this is part of then linking to SOSA, right? And so you have a SOSA observation, you have from geosparkle, geolat long, so you have position, and then you have a whole bunch of nice things from SOSA, like feature of interest, a sample result made by sensor, observed property and phenomena time. And that then makes things, assuming I don't trip and hurt myself, interoperable with other people that are producing sensor data, right? And so these are sort of the ideas that I have loosely in mind for what that parts of that ontology could be. Okay, so all right, so then the second thing, Lewis, do you want me to talk or do you want to talk or? Okay, yeah.
Okay, folks, going back to the the agenda for this year. Okay. So the purpose of me being here really is to just try and advance, I suppose, the development of an open API and the server implementation to facilitate a demo in simple terms. We're not starting this from scratch by any means. I think that the Open API kind of hack track here is it's leveraging stuff which was done over at the OGC more recently on the coverages side, which I think is a good starting basis for where we're trying to go. There's a lot of maybe disagreement between use of the term coverage, but for the best attempt here really is just to leverage whatever I think has been agreed over the OGC side for the time being. So the issue here was, or sorry, the prior art here was essentially the OGC coverages open API, which is linked to there. If you go into the notes, you'll find that. And a kind of dummy application that Jane had put together, which essentially, I'll go on to explain, augments, I think, where we think that coverages API is to go. We had suggested that we pick Node.js as the server implementation. And then we start thinking about other advanced work, which is like maybe bridging into the linked data perspective on these things. But very quickly, if you look at the design hack subdirectory, you'll see here an Open API directory. If you go into that Open API directory, you'll see docs and this PowerPoint presentation, which was actually This is actually presented, I think, by whoever the attendees were to the OGC Hackathon, which happened recently in London. And this is relevant because it gets us towards understanding what an API would look like to get coverages, because it establishes the scope for that. But you'll see here that current scope is that first sentence, I'm looking down further, it's the very first sentence. It establishes how to access, but not how to put, not how to acquire. It's just how to access coverages. And I think that's what we're wanting to overcome here, right? Is the point of generating this data model is because we're talking about how to acquire.
So does everyone here know what a coverage is, first of all? Okay, so that may be, okay, so a coverage is basically just gridded data. It's a way of describing that you have data that has a point in time and space, right? Raster could be a coverage, right? You can have different types of coverages in different formats. This is just a general way of saying that I've got some gridded data objects that both have a spatial, temporal, and some measurement that's associated with that point in time, right?
Thank you. Yeah, that can just stay out there, I think.
Okay.
Okay. So with that in mind, and you can look at the rest of this presentation here. And again, you know, this whole thing about coverages, you know, depending on what the applications are, the use cases are here, you know, people maybe have some additional opinion as to what that coverage terminology is, but for the time being, I think for the purposes of us moving forward here, we're talking about some moving object making an observation and us capturing that observation for the time being. Whether we relate that directly to the terminology for coverage, I don't think it's neither here nor there for the immediate purposes. So with this being said, you can look at the rest of that slide deck when, you know, if you want to. But going back to the Open API track, essentially what we'd done in preparation for today was to produce, or let me say, was to fork the existing Open API specification, which was generated. So this is a beginning sample to get those coverages, not to post any data up there. So we've got stuff like the APIs currently are sitting at a get of capabilities as to what the API actually achieves, get conformance with which OGC specifications or other, you know, standards or specifications there are. You get the collections. We can collect a collection of or an individual collection ID. We can get coverages for a particular collection ID. And we just kind of go down here, nested further down, we'll see that we can get a coverage ID, an individual coverage from a collection of coverages. We've added here, we have a domain set. These are described within the Open API, a range type of coverage. And this is where we are, right now, we're having a look at some of the stuff we've added, right? Terminology here, temperatures, is not the correct way that this API should be implemented. But for the demonstration purpose, it was the idea that our input data set was measuring temperatures at a lat long, you know, some XYZ, maybe T coordinate, right? So we would build that up as we go ahead here. Where are we? Temperatures and then an individual temperatures ID. So depending on what the response object would want to get from there. So essentially what we have now is, although these were implemented as gets, we're changing this to post. And then the purpose of that Open API track is to literally write the JavaScript implementations, Node.js implementations, which would back this up. And it's as simple as that. That's what we're trying to achieve today. If anybody's interested in doing that, then jump on board with this track, really. Okay.
Yeah, and I will make one comment. Even though the goal isn't to do much beyond the hacking, it's also though to identify as you're doing it areas where we could then bring in other linked data vocabularies, how these links actually work. So this idea of observation collection, right, was brought up yesterday as a coverage as being of a type observation collection. And so you could in fact have other sorts of endpoints that may not be necessarily be coverages because they may not be, from moving objects. So you have the spatial temporal component, but you might want to be able to cross-reference those, right, through the API. So, and that's work that the OGC I don't think really has had a chance to think through because they've sort of been working on atomic endpoints versus endpoints, which may retrieve data that's related to each other. And so need to be able to breadcrumb between those URI endpoints. But in any case, so that's the goal there. There's two other topics. So the third topic, if none of this interests you, what we'd like to know is how do we build community? One of the things that we're doing this for is not just to do it, put it on a paper, put it on a website, and then walk away. We'd actually like people, A, to influence what we're doing and be able to contribute, but B, also, be able to excite people, get people, sort of interested in looking at this, right? And particularly, how do we do hackathons? Where do we do hackathons? Those sorts of things. So if there's, none of this other stuff as far as technical stuff, is of interest to you, then that might be a topic that if there's, people that might be interested in it. There's a fourth topic, which we didn't put on here, but we have a Slack channel, by the way, which at some point in time we'll put it's in the agenda. And there's a topic in the Slack channel called decentralized identifier. So there's a W3C effort to create, and this is funded by the Homeland Security and a few other organizations. How do you identify things in the world that have URIs that are not dereferenceable URIs, say a blockchain element or a IPFS hash, right, which is a decentralized file system. And so they came up with this decentralized identifiers specification. And right now there's specifications for there's something called Sovereign, which is a blockchain thing, Ethereum, which is a blockchain thing, IPFS, which is a file system, and a few others, right? And so one of the issues that I have is coming up with identifiers for what a aerial thing is, right? So how do I talk about that? Because it's a decentralized thing. I mean, it's not something I can dereference, right? And so there is some work that people have been thinking about for Internet of Things objects, right? Creating decentralized identifiers for them, creating methods for creating those identifiers, which then are published to a registry that the W3C is actually looking after right now. So that's an additional topic, which I think a couple people all expressed potential interest in. But it's more or less a infancy nugget in my brain right now. So, but it's stuff we know that we have to address at some point in time. Okay, so with that, could we get a show of hands just to see if we have viability? So how many people are interested in working on the ontology, vocabularies, sorts of topics here? Okay, I think we've got a group. How many people are interested in working on the Open API? Okay, we definitely have a good collection of folks there. How many people are interested in doing sort of the community building thought process parts? Okay, so we have two people right now, three. Okay, three people. That's good. And then how many people are interested in this whole DID thing? Okay, so we okay. I think I have enough that I can get. We can sit for a while and start to walk through it and make some progress. Yes. Okay.
Modeling the metadata, which is maybe entirely encompassed by the ontology development, but they aren't, you don't necessarily progress in the same way.
Yeah, so the way that I view this is that you need, sort of foundational ontologies, vocabularies that define things and relationships. Then you create schema for linked data documents, right? So linked data documents get sent and received by the APIs. Certainly we need that structure of what that schema looks like, that reuse the URIs from the vocabularies that we're developing, and then be able to link to other vocabularies, through feature of interest or these other sorts of things that then could be, something that's contained in info. So if you're sensing something out of the field, it's a feature of interest, use those hooks to then more broadly describe what it is you're talking about.
Right, so I appreciated that last part. I was thinking that as the downstream part from the nominally more trivial, but actually kind of interesting challenge of saying, what is it we're actually trying to describe? And the act of describing it in a thoroughly ontological way is its own major challenge.
Mm-hmm.
But I wasn't clear if you all feel like you've comfortably achieved the goal of just making the list of what the things are that need to be described.
Well, at this point, I think I'd like to leave maybe that as a topic for that group. At this point, Pierre.
Separate thing or part of this.
Well, like based on the model that you showed earlier, Chuck, like the outline of the things, I mean, I think that's a good place to actually start the group by first listing what all the things of interest are, and then seeing if we can do natural categorizations based on that first bottom-up approximation of what's there, like scoping essentially first, because it's easy to go way off.
Exactly. And that's part of it. So that's a very good point, and that's why I was trying to scope this a little bit. There's also some other resources. So there's this thing called Drone Code. Did I get that right? That has and I have the link off of the agenda page, that has in code essentially definitions, they're defined statements essentially for their code of a whole bunch of different types of vocabulary objects that you can send and receive information about. So you can send body type, which is helicopter type, or all these sorts of things. They have broad categories there. That's another place where sanity checking of what the general pattern is make sure that things could get binned into each of those places. So you actually have some sort of data objects to ground what's going on. So.
So I think what you're referring to is the Mavlink API, and so that would be a great place to check the drone model that you're building. In terms of general what metadata we want to capture, I would agree is nowhere near finalized, but that's what Andrew and I did with creating that minimal information framework. And so the place to start if we wanted to start writing lists, and so this was something that I thought we might do in the community group, is this idea of creating community schema, and part of that is agreed upon. These are the things you need in order to publish your data as such that anybody else could reuse it. So we would start with that minimal information framework that we did develop through multiple case studies or whatever. Publication pipeline is slow, but it's coming. But the models there, so that we could start there with that. So I don't know if we need to revote and see if people have.
Nothing's locked in stone.
Yeah. So you can move around. I think there are multiple threads that the community one could go to. So if you don't know where anywhere else to go, come to that and we might split ourselves. Otherwise, model, DIDs, OpenAPI.
Yep. Okay, so where to break up to? You're already here. Are you comfortable? I'm assuming you may need that. Where do you think you need any of the display, you think, or okay, so maybe over in this area. I don't know if that's too close. Okay, yeah, that's true. Yeah, I didn't look to see if there was anyone online, but yeah, okay. And then Doug and I will sit and chat for and then, yeah, the community stuff in the back corner, because they probably don't need quite as much technology. So, and by the way, thank you for coming.